Yes, so I'm François Helg, as Bob said. I'm the CTO of Privately, a Lausanne-based startup. And what we are trying to achieve is to keep children safe online. And what I would like to do today is to, just in 5, 6, 7 minutes, tell you a bit more about one of the recent projects that we've done with a large broadcaster in the UK, and trying to give you some of the learnings that we've learned along the way. So just the use case, so you try to understand what at least we are trying to achieve. So one of the things we were trying to do is to support the development of a custom keyboard that is meant to be used by the child as his first keyboard. And what we want to do is to provide instant feedback within the keyboard. So the goal is to develop NLP models that are able to interact with that keyboard and provide instant feedback. And I see you coming. So the goal is not to spy on the child. The goal is not to report to the parents. I've heard Edward Snowden yesterday as well. And so the goal really is to provide insights and educational content to the child himself, and not to report anything to anybody, actually. And one interesting thing is that I will not really talk about during the presentation, but if anybody's interested, I can discuss more about that. But what we've been doing is to deploy those machine learning models to the edge, so to the mobile application itself. So none of the content is actually being shared anywhere. So everything stays on the phone. And what we've delivered, or what I'm going to talk about, are 3 models. So one model to spot hate speech, one model to spot toxicity, and one other model to spot emotions on text. So what we delivered in that project are basically 3 or more classifiers, but at least to analyze and to report anything about hate, toxicity, and emotion of text. So there are actually many learning and many challenges that I could mention in that talk. But I decided to focus on one challenge, which actually had a big impact on the type of assets that we would use, or what actually we had to redevelop, because what we used off the shelf was actually not providing enough accuracy. So as you can understand, so if we need to actually analyze text written by children, most of the interaction that children will have on their phones, or what makes sense, or where it makes sense trying to have an impact and to provide real-time feedback, is if the child is writing on social media, chat application, and trying to give some meaningful educational content or feedback. So typically what the system would, or the type of text the system would be confronted with typically is those type of text. So something with mention, a lot of abbreviation, a lot of words or letters being repeated a lot of time, a lot of emojis, emoticons. So if you use off-the-shelf NLP package, so typically they are not really well suited to handle those type of text. So what I'll try to do in the next 4 or 5 minutes is to walk you through the typical elements or assets that you use into an NLP pipeline, and trying to tell you basically what we've tried and what we've decided to use, because they basically provided the best accuracy for the needs we had, and explaining also some of the constraints we had. So if you're trying to use a machine learning based system to do NLP, so typically today, what you're gonna use most likely are word embeddings, and there are different type of embeddings that you can use. So you can have embeddings for words, for subwords. Now you can have for sentence. So we've experimented with many of those. And in the end, if you need to, yes, so the type of challenge we had was abbreviation or misspelling. So if you use full word embeddings, then you'll have a lot of out of vocabulary words. So then there isn't much that you can do with those things. So we've seen that using subwords embeddings, mainly those using byte pair encodings, were providing the highest value. And we had access to a large-scale social media data set, So it was actually enough data so we could retrain those word embeddings to feed them to the type of text that we had to analyze in inference. So we've compared that with off-the-shelf byte pair encodings that you can get, typically trained on Wikipedia. And those for our domain were providing much more or much better accuracy. So we've done the same for the word embeddings. So we've used then sub-word embeddings, and we've seen that they were much better suited to handle out of vocabulary words. And we've also trained those on that social media corpus. And one important thing is, or one of the challenges that we had to face were actually we had to provide and ship those models on mobile phones. And as you can imagine, you cannot have 2 gigabytes embeddings, for instance, on the phone. So we had to come up with models which were small enough. And in the end, with all the optimization we've done, reducing the number of elements in the vocabulary, doing some quantization, we were able to come up with models which were between 3 and 7 megabytes, but providing very comparable accuracy to much larger scale models. And in the end, one of the learning was one of the tasks, as I mentioned, was being able to analyze emotion on text. And there were not many available data sets to do that, so we had to collect the data set ourselves. And what we've seen is, at least for that task, using distance supervision. So not having to, of course, as any team, and we are still a small team, so having to label a lot of data is as you know, difficult. So we've used, with quite some success, distance supervision to gather the data set. And in our case, that meant actually using hashtags on social media, which we thought would be very close to, or would be very closely associated with an emotion. So gathering or using those hashtags, being able to gather a large-scale data set, and then having that kind of fuzzy labeling, that actually provided a lot of meaningful insights. And we could use that models to predict emotion. And we've actually complemented that with 3 other models, 2 of sentiment analysis, and we actually had 2 models for emotion, 1 which were fine-tuned for neutral. And so the combination of those 4 models were actually providing very significant accuracy. And all those models, they have been tested on a data set that we didn't have access. So our partner had data that only them could access, and we've basically validated our models on that data set. So now we had to, the last learning was we had to, I mean, the one that I'll discuss was we had to iterate very fast, because as probably everywhere, but in industry, it's even probably more relevant. So we had the deadline, we had to deliver very quickly. And when we realized that we actually had to iterate, label more data, trying to find out where the model were failing, we actually developed our own sets of tools to ease and being able to iterate faster. So now we have a bunch of tools that, for instance, helps to visualize the tokens which typically provide the highest errors. And then we can fetch, we also have the pipeline then to fetch more data. And that's a way that we found out that would basically help us to label meaningful data. So we could see where or what type of data is failing, gather more data, and then we had labelers that were able to label that data. So I have many more things to learn or to share, but don't have time to do so. So if you're interested, I will be there at the break. So feel free to come and talk to me. I will be happy to answer your questions. Thank you.